City University of Hong Kong School of Creative Media, and I have the honor of being the session chair for the first session of this conference. Some housekeeping first. This is the last call for Mr. Connor McKeown. Please raise your hand if you are in the room. Then I regret to announce that one of the speakers of this session, Connor McKeown, is missing. So we will have more time for discussion if we so wish, or we can go and break for lunch earlier. This session has two speakers, Sebastian Möring and Michael Streubig. And Sebastian shall go first. Sebastian Möring comes from University of Potsdam. And Sebastian will talk about, Sebastian's talk is entitled Understanding Single-Player Computer Games as Experimental Systems. And we do a Q&A after each talk. Yes, Sebastian.
Thank you, Ollie, for this extremely kind introduction. So I bracketed the single-player part in my title because I think what I do also counts for multiplayer games, but it therefore also counts for single-player games. But if we only look at multiplayer games, it will be maybe slightly different. So the topic of the conference regards knowledge. So I was wondering how new knowledge is created in computer games and stumbled across the notion of experimentation. So if you imagine during the program discussion for the conference, I was the one who was bringing up the idea of experimentation, so I just put it forth anyway. So I start with the observation that computer gameplay is often described as experimentation to some extent. So to give you an example, our host, basically, or part of the host institution, Gordon Kalea, says during the first hours of playing a new digital game, you adapt yourself to the game's mechanics, physics, and rules. You take the first uncertain steps in the unexplored spaces, experiment with running, jumping, leaning around corners, and geographically rich game worlds. You are likely to explore the first area slowly and thoroughly until you form a cognitive map of the layout of the world, country, region, or city. So he is using the notion of experiment with regards to games, and he's also using the notion of exploration. So it seems these two notions play a role. And then there's Espen Aarseth, who's also speaking about how we start playing computer games. He says, in order to progress through the learning stages of a game, the player must explore various strategies and experiment with different techniques. So exploration, experimentation. And then there's Will Wright, who in an interview says how he first played Bruce Ardwick's Flight Simulator. So he says, the first thing I did was I went and started exploring the behavior space, trying all the different things with the airplane. What happens if I go straight up? How far can I go? What happens if I crash? What happens if I do this, that, and the other? So I could carry out experiments in this world, and in running those experiments, I could get a more accurate view of what the internal model was. So he's also referring to experimentation. So usually these observations refer to the beginning of playing a computer game, but I believe in my talk I will try to argue that experimentation actually doesn't necessarily happen at the beginning of the computer game, but actually happens when we're way further down the road, so that we are actually capable to do experiments. How do I come to say so? There's a German historian of science, Hans-Jörg Reinberger, investigated how researchers in the life sciences actually find out novelties about their subject area. And he was trying to describe the structure of the scientific discovery and uses the term or the notion experimental system for that. So I think although computer gameplay is often conceptualized as experimentation, and even scientific experimentation is at times likened to gameplay, there's reason to assume that not all kinds of computer gameplay are allowed to be called experimentation. Hans-Jörg Reinberger's theory of the experimental system distinguishes experimental systems from testing devices. Hence, the question for this paper is, oops, sorry, I was leaving that out, so experimental system versus testing device. question for this paper is, which conditions need to be fulfilled to consider played single-player computer games as experimental systems? To answer that question, I will first draw on Weinberger's theory of the experimental system a little bit. I will test it with the computer game Limbo. Then I will see what conditions need to be met for games to work like experimental systems. So I will draw on two conditions. I think there needs to be a certain openness, complexity, and high degree of emergence. And there needs to be something that is called, or has been called, innovative gameplay. And eventually I will want to briefly discuss 4 cases of how computer games are experimental systems or have participated in experimental systems on different levels. So, the experimental system by Weinberger. It usually works against sort of a common sense understanding of experiments as, quote, singular well-defined empirical instances embedded in the elaboration of a theory and performed in order to corroborate or to refute certain hypotheses. So, so this is basically what Will Wright is actually saying when he speaks about playing Arctic flight simulator. He says it's like kind of a scientific process. It's kind of a hypothesized experiment, change your hypothesis type cycle that was going on. So he's basically using common sense understanding of the experimentation as if the process of playing a game was to test the hypothesis, or as if it would be a theory-driven activity. This is quotes from Weinberger. He's basically building his experimental system against this and says that there's basically a problematic understanding of experimentation, since experiments are often not singular instances, but systems of experiments, and they do often not work within well-defined research experiments. So they are way more fuzzy, it's way more difficult, or it's way more complex and difficult to get. To give an idea of what the experimental system is, Weinberger says it must be capable of differential reproduction in order to behave as a device for producing epistemic things. So that's this. Whose possibility is beyond our present knowledge, that is to behave as a generator of surprises. So computer games, to be experimental systems, have to some extent to behave as a generator of surprises. Furthermore, the experimental systems consist of epistemic things, and those are like entities whose unknown characteristics are the target of an experimental inquiry. So a characteristic for them is a specific vagueness, because the epistemic thing, that which is to be found out, is incorporating the unknown. So we don't know actually what we find out. That is usually, so that there's a paradox that epistemic things, so things that we want to know, are absent while they're at the same time sort of negatively present already in the experiment. And simultaneously, this sort of unknown is sort of negatively contained, that's what I just tried to say, in the technical object that is the other part of the experimental system. And the technical object belongs to the experimental conditions and experimental conditions. And technical objects embody the knowledge of a given research field at a given time, which is much less vague and more stabilized than the epistemic thing. So, in a way, technical objects contain the scientific objects in the double sense of this expression. That's what Weinberger says. They embed them, and through that very embracement, they restrict and contain them. So whatever we set up in order to find out something will simultaneously already define what can be found out, right? Everybody knows this with a certain methodology. So in like this experimental system, it usually happens that epistemic things turn into technical objects, and that turns into epistemic things again. And you could see this as sort of a continuum between that there exist all possible degrees of hybrids. So Weinberger says epistemic things are historical and often shaped only in retrospect after a series of experiments has been carried out. So one example is the microscope. It is a sufficiently stabilized result from an experimental system regarding optics, for instance, right? So it's knowledge gained in materiality. But it turns into a technical repertoire of other experimental systems, for instance, in biology, if you want to look into cells. What is important is that these two elements of the experimental system are different yet inseparable. So let us briefly consider the game Limbo, to which extent we could say that this is an experimental system. I guess everybody knows Limbo, that is an independent game from a Copenhagen-based game developer Playdead from 2010. Was quite successful. In a way, it's a classic 2D platform game. Player has to move the avatar from A to B and overcome complicated obstacles. I just call them as a genre term, but that means like dangerous circular saws, enormous gaps, harmful organisms, you know all that. So the hypothesis would then be that Limbo is an experimental system because it is a generator of surprises and requires the player to constantly discover new things, epistemic things, of how to deal with challenges, so how to deal with the game. It's basically always like an epistemic thing that we're trying to find out. And to do so, the player usually performs trial and error tests to find out how to avoid that the game terminates prematurely, so that the solution gets slowly shaped and the epistemic thing becomes clearer. So, yet some players are frustrated with Limbo. So there was a comment on the internet, where there are many comments, but this one was there too. So he says, like, instead of asking you to apply what you learned from your previous path, the game keeps changing the rules so it can kill you again. It's as though it's making things up as it goes, like a rambling first draft that could use a good revision. So playing Limbo, basically, does actually not mean to accumulate new knowledge which you can then use and use, because it seems to change later on. So it's not a matter of accumulating knowledge. So I was wondering, perhaps one can argue with Reinberger that playing Limbo is maybe not an experimental system because you're not really experimenting. Reinberger says epistemic things, so things to be found out, are not simply hidden things to be brought to light through sophisticated manipulation. So whenever something is hidden in a game, it seems that it just needs a sophisticated manipulation to be brought to light. So if this is true, then Limbo is perhaps not about finding epistemic things, but about finding hidden things, so things which have been implemented there by game designers beforehand. Then Limbo has to be considered a testing device. So playing Limbo does not generally bring across novelties, but it just brings across what designers have implemented beforehand. So what to do with games, what do games need now to actually allow for experimentation in the sense of an experimental system? I believe, as I suggested before, that there are two things: openness, certain complexity, or high degree of emergence. Authors who refer to that with regard to game are Jesper Juhl, and there are also computer scientists, Jochen Fromm, who speaks about complexity, and perhaps something that we can call innovative play, but we can also call it differently, as has been done by Espen Horsett. So let me start with the first part. Jochen Fromm. So Jochen Fromm, for instance, distinguishes between different types of emergence or different types of complexity that systems actually can have. So type 1, simple ordinal emergence, is to his understanding comparable to the intentional design of a machine, with specific and fixed roles for each element, which never change and are always the same. And he likens this to the gears of a watch. And there are different degrees in between. To the highest form of emergence, that's type 4. And he says emergence here on this level represents the highest degree of complexity, life, and culture. So, yes. So, to give you an idea, there's also like a second type of emergence that's called weak emergence, which basically consists of very simple feedback loops, which would be in Limbo to do the right thing or the wrong thing, right? That's the feedback. If you do the wrong thing, then it ends. If you do the right thing, then you can continue. That would maybe be Limbo. And a game with a strong kind of emergence, which is culture-like, would probably be EVE Online. That's what I said. It's a multiplayer game. And because, I quote, EVE Online has its own economics, politics, and trade system, but built almost entirely by players in the 10 years the game has been running. So there are very different levels of complexity. And so I think that is one thing that needs to be done. If you just fulfill like this simple feedback, then you're actually just finding out the hidden things that need to be done in order to keep the game going, but you do not really experiment in the sense of the experimental system. Instead, you need a higher degree of complexity. So now, let me get to the other point, innovative play. Reinberger says for the experimenter, he says the more he or she learns to handle his or her own experimental system, the more it plays out its own intrinsic capacities. Also, it said about innovative play something similar when a player invents, or to get to innovative play means if a player invents totally new strategies and to play the game not to win but to achieve a goal by means that are previously recognized as such by other players. So to get there, the player has to go through all other stages beforehand. So what Reinberger says is that an experimenter has to get to know the experimental system. Simultaneously, the player has to get to know the computer game. These are all categories by Espen Aarseth. Thought I forgot this. So you start on the level of superficial play. This is basically what Will Wright referred to as experimentation already, but I hope that experimentation actually only happens on the 7th level. That's basically roughly the distinction. Ollie Leo and I used this in last year's DIGRA conference, and we distinguished between 3 different modes of playing with Heidegger according to his ideas of regarding authenticity. So if you would see this in Minecraft, you could say like just simply being thrown into the world of Minecraft is sort of an undifferentiated mode. You simply are faced with the game and you have to try to make it work. In the inauthentic mode, which in the survival mode of Minecraft means all other levels from light play, partial completion to total completion, repeated play and expert play, basically just means to play the game as it is meant to be played. So all strategies that are there already and all strategies that are laid out as being useful, also called skill rules, for instance, by Bernard Hughes, would happen on this level. And only in the authentic mode of computer game play, we are transcending sort of the inauthentic mode and fulfill our own projects, which would be one example, would be to build a 16-bit computer in Minecraft, which has happened, or actually my other favorite example that I forgot to mention is like the elevators that were built. So elevators were never foreseen to exist in Minecraft, but people managed to use the game in such a way that they built elevators, so you can step in, push a button, and then be lifted up. So let me conclude. I believe there are basically 4 ways of how games can be regarded as experimental systems, or how they participate in experimental systems. And actually it's 5 ways, but because a testing device is not an experimental system, it has number 0 in the very beginning. So games which are testing devices are just sufficiently stabilized and fixed and do not bring across any sort of new novelties that we have to deal with. Then there's the first level that are glitches or bugs, right? I don't know who knows everybody should know the rocket jumping example in Quake 3 Arena, which was basically exploited. It became an epistemic thing because it was found out how to do it, but the moment it was integrated in the normal gameplay, it sort of gets in and of itself stabilized and gets a technical object and is being used as a standard strategy. Then I would say there are games with sufficient complexity like the Kerbal Space Program or Minecraft, which allow to build new things or invent new things within the structure of the computer game, which do not rely on bugs or glitches. Like this, for instance. It's a fully functioning 16-bit computer built within Minecraft through Minecraft. Then I believe there's a higher level, which is the game development process, in which playtesting happens, and it requires actually to find bugs and glitches, but it's also a higher level where add-ons and mods and anything is contributed to or is added to computer games, so that they constantly change between epistemic thing and technical object, and so they're made more vague in the moment you add something new, and then the moment it gets standardized, it's it's a technical object again, so the idea of permanent beta basically means that computer games are constantly sort of in a process of being an experimental system. And then on an even higher level, that is the idea where computer games participated in experimental systems which were not about computer gameplay, but about knowledge in different fields. So I'm not saying it for time reasons, I have another point there as well, you can see it in the paper, but for instance, if you think of the Prussian Kriegsspiel, that actually was invented to train Prussian generals, developed from a knowledge discourse concerned with questions of the calculability of war activities. So the epistemic thing was how to calculate war. Then they invented this game to actually make it happen. Then you had an interplay between this game and what actually happened in war, and the game was always trying to be improved in order to better simulate war. And eventually these questions turned into questions of the calculability of contingency in and of itself, which sparked the development of a mathematical theory, which is nowadays known as game theory, interestingly. So in that regard, on an even higher level, computer games participate in experimental systems. So what I believe is that all the higher levels of this experimentation also rely on the lower levels of experimentation all the time. So some games get up to level 2, most games are at level 3, but then we have to distinguish between game development process and gameplay. And yes, that's basically it. Thank you.
Thank you, Sebastian. Do we have any questions? There's one. Okay, we'll get a microphone.
Switches are on, but it's not working. Maybe I start shouting.
I can hear you like that.
Good, wonderful. Can you go back to the previous slide? Not the previous, not the previous one. No, there's one. I'm not sure, my memory might betray me, but I would say that the rocket jump actually comes from Quake 2, where it is that emergent phenomenon. In Quake 3, if I remember correctly, it was already integrated kind of by the designers as a feature of the game. So that would be a wonderful example of what you're trying to say, right? That becomes basically, goes from level 1 to level 0. But that's exactly my question. I see the drift of what you're doing here. I'm just asking myself, isn't that more of a circular move? Isn't that something that happens, that we renegotiate all the time, that it's really hard to label a game or a phenomenon in a game as one of those categories. It's more of like an epistemic process that we go through in interaction with every game.
I would have to unfold it much more to actually account for what you say, because I think you're right. I have to cut it down for time reasons, but sure. And I think I've also not fully fleshed it out yet, but there is something to be found in like there are experimental systems in different stages. But what I was mostly interested to say is that what we do at the very beginning of the community is maybe not that sort of experimentation which sort of creates new knowledge. So this was the idea of this.
Thank you.
Oh.
There's a question from Stefano. And let's go ahead.
So Sebastian, I found it super interesting, especially the fact that you included the game development process in this own learning thing. But my question is not about that. How does your vision integrate or contribute or criticizes, for example, an existing sort of mode of thinking about experimentation in games, such as, I'm thinking Jonas Lindelof, performative actions, explorative actions. Is this like a further enrichment of that vision, or does it counter it? How do you position yourself in relation to that? In case you know it, in case you don't know it.
Maybe you could elaborate on that briefly.
So Jonas talks about performative, explorative actions as actions in-game, so it excludes game development, in which you are testing, as Gordon would say at the beginning, the boundaries of the world and your avatar, right? So this testing transforms into knowledge that then the player has in a stable fashion to operate in.
Yes.
So first you go into the experimentation phase, and then you go into a using knowledge, which he calls performative. You seem to be given a lot more granularity to that, and I wonder if you related to that somehow.
I must admit, so I don't relate it officially to that, but I would probably agree if it's what as you say. Yeah.
So you can hear me, right?
I can hear you.
So no, I just want you to elaborate more on the comments on game development versus gameplay, because I think adding to the idea of circularity, this division doesn't get like confused sometimes. Just elaborate more on this idea of game development versus if there's really a division that.
Yes. So I should elaborate more on why I make the distinction between playing a game and experimenting within a game, and then having a game development process as an experimental system officer. So in the core of my idea is the computer game. So when I start actually, you can also see this as like circles, right? Going from the inside to the outside and getting a border. And I believe like that a game like Limbo actually gives you the impression that you would find out new things all the time, but it's actually has been hidden there already. So it's like searching for Easter eggs basically. And on another level, you are basically able to actually create new things and therefore new knowledge within the structure of the game. And then I'm going outside of the inner structure of the game, because in the game therefore the third level also accounts for add-ons and mods, because those are moments when you change the game code. Then you cannot invent new things within the game anymore, but you have to step outside basically, and you are working on a different level. And this is, of course, I have to account for this because this is a stage that every computer game is in at some point during development. So even if Limbo as a game appears to me as a testing device because I play it like that, it used to be an experiment, it used to be part of an experimental system during the design process, because it was an epistemic thing, because the designers tried to find out how should that play out and all these things. And then they decided which characteristics they wanted to stabilize, and they decided to make it a fairly completely stabilized or an object where most gameplay possibilities were already there, so to speak. Does that answer your question?
In the third point, the game development process, there's also a point that an element that I don't see there. That is the element of localization. That is the transporting of a game from one culture to another living, breathing, existential, environmental, and culture. How do you think the element of localization is applied in your scheme?
I think I did not want to account for the whole idea of how games are being designed and how they are produced. I just wanted to see that in relation to how games are played. So maybe this is something that I could do in future work, but that was not my intention here, so therefore I don't account for that.
Just one more question from Mark.
Yeah, so this probably links the presentation to the keynote. Knowing your background in the simulation stuff, in philosophy of simulation, there's this interesting debate or discussion between computer simulations and computer experimentations. So you don't even mention simulations by word in this presentation. So how would you if you want, you can just skip the question, but how would you see the difference between these games or computer games as simulations and experimentation?
For the case of the Kriegsspiel, I would say there is no difference, because that's exactly what the Kriegsspiel has been there for. It's been there for to simulate war and to simultaneously experiment with different strategies how to do war. I don't see that distinction.
Okay, so then you just, that's okay. But there is, but you're aware of this debate in the philosophy of simulation field, which is making this distinction and having this. Okay.
Okay, I think about it.
Okay, there's a question in front of us. No, I find this very interesting, especially in relation to how players can reflect on themselves. Oh, sorry. I find this very interesting, especially in relation to how players then can reflect on themselves and transform the way they play. I was wondering whether you account for the idea that, I mean, the way I'm understanding this, at least, it's like you're experimenting in relation to a system that is already in place. What about experimenting with yourself as a player? So when you're playing Limbo, for instance, I can see how you're using it as a testing device to see how you should play gameplay to not obviously die. And I agree, I played them also, I agree that there are sort of very few, or like there's generally one way in which you can play to not die in certain puzzles. But there are players who make their own goals, so to speak, in the game, and this is part of the matrix. Like,
Test 1, 2.
for instance, my nephew once was playing Castle of Illusion. He didn't really care about the goals that are set by the designer of the game. And he was just creating his own sort of, now this is not considered a game of Americans, but he was creating his own goals. And he was experimenting in his own ways in relation to the system he created in his own mind, if that makes any sense. Do you account for this in any way? Because I think we do experiment based on...
Yeah, sure. I mean, that's the big elephant in the room, actually, right? That you have to somehow account for. I'm not always sure if that is. I haven't decided on that yet. If that is an element of rather being also testing or something, because there's not really anything much new that you find out.
Well, you can test, for instance, I don't know, you can have a playthrough of Limbo and you want to say, okay, I have this particular goal in mind that I want to pass the game in an X amount of time.
Yes.
And what are the
What are the best ways for me as a player to pass this game in X amount of time? And there's still an element of experimentation in that. Although it's not related really to the game system, but it's a goal that the player creates himself.
Yeah. So I think what I'm trying to do is to see how that happens within the materiality of the game, because I think this is like sort of putting a new gameplay condition on top of an existing one.
Exactly.
So even that racing you can only do within the material constraints of the games, but you can do something different. But I see where you're coming from. So maybe I should also put that or make that more explicit in the paper.
Thank you.
Sorry, I think in the interest of time, this is where we stop this Q&A and move on. Let's give up one more applause.